Okay. Hey everyone, we're back with another episode of the Utility Strategy Podcast. Um, and today's episode is going to be summarized in one word, GPR. Or is that actually three words, I guess, right? So, anyway, today I have with me Sean McConnell from Big Man Geospatial. I hope I pronounced that correctly. And let's, yeah. So let's just say that if anyone knows how to work with GPR, it's these guys. So without further ado, Sean, how are you doing today?
I'm doing great. It's a pleasure to be on, and it's always a pleasure to talk to the 4M crowd. You guys are great.
Thank you, very much appreciated. So give us a brief. Who's Sean? What are you guys up to?
Okay, well, my name is Sean McConnell, and I'm a senior project manager here at Bigman Geophysical. We do all kinds of subsurface non-destructive testing. That's what our company specializes in, and we're pretty much from the top down. We do it all right now. So, starting at the basics, we train people, we sell equipment, we rent equipment. We can do surveys ourselves. Sometimes they really need experts. They'll send us out there. And most of what my department does, in particular, is back-end processing. So a lot of people nowadays can get their hands on this equipment. It's not very hard to use in most types of non-destructive testing. And then when they see it and they go, I don't know what this is, or I need to make sure an expert has seen this and I'm not wrong, they can send that to us, and that's what I do. And it's a really good job. We do a lot of different kinds of equipment, but like you said in the introduction here, GPR has become the gold standard. It's the equipment that has probably the lowest failure rate and the highest confidence in its results. And the thing to remember with all non-destructive testing, and I like to just front load this, is we have the same rules as medical testing in the sense that we can never, ever, ever, ever make a 100% conclusive statement. It's your doctor won't say this is cancer, this is not cancer. They will say we see cancer, we don't see cancer, and this is because of the nature of not being able to verify something that you can't just expose. And that's always the case of non-destructive testing. If you're exposing it, that's destructive testing. And so we're stuck playing that same game where it's just like a doctor, but it's the same deal where if you might have tumors, you really want that MRI, even if it's not 100%, maybe 99%, still pretty good to get. So we do an awful lot of subsurface imaging to find many, many, many different kinds of things. My background, and actually Dr. Bigman himself, is archaeology, and then so is Robert Thieberge, who's wandering out behind me. So it's surprising that you would have archaeologists in this field because archaeology is a pretty small percentage of our contracts. But we all came into this because we were using GPR to find archaeological sites, which in America are unfortunately not usually the big stone sites like you're lucky enough to have in Israel. Those are really easy to find in GPR. If you can't see a giant stone rectangle, you're probably not very good at your job. For us, we're looking at totally decomposed wooden sites. And so in the real sense, if you took a trowel and scraped the dirt, this is just going to be different colored dirt. And to be able to find that in GPR really takes a lot of talent and a lot of training. And so archaeology for us has been a very good litmus for employees. If you can find that in GPR, you're not going to have much trouble finding pipes. And so weirdly enough, a lot of archaeologists have started to kind of filter into this industry because all of archaeology is basically subsurface, right? Well, most of it anyway. And so we've come in, and most of our clients are not archaeological in any way. They're not really worried about preservation. They're more interested in not hitting a pipe and utilities of other types. We do get people that are worried about the movement of water. It could be a leaky pipe, could be just totally the geology. They don't want buildings moving after they built them. Very expensive errors. And what a lot of companies are starting to realize, and the reason that I'm so happy with 4M Analytics is you guys have such wonderful posts showing them how cheap it is to find this stuff in the first place and how common it is to not do that and pay a whole lot more money.
Unbelievable.
It's staggering to me that usually by the time a client has sent us out there, it's because they've realized that somebody has made a terrible mistake. And it's like, hey guys, this would have been low thousands of dollars to have us do before you designed this building, and you could have just moved it 3 feet. Like this is just empty land here. You could just save yourself a ton of trouble. And instead, they're calling us out there when there's already an excavator crew sitting in their cabs doing this, waiting for us to finish.
It's like, okay, I don't want to make anything more, do any more damage. So I'm just gonna sit here and let the experts take care of it.
And that's, once they've realized that the as-builts are wrong, they're hiring us basically to make a much better as-built.
Yeah.
And
Yeah.
we get kind of this interesting back and forth because we work with a lot of companies that have surveyors on hand. At construction sites, they're very common, and the surveyors can get kind of snotty with us because surveyors have such excellent accuracy, and they like to brag about their accuracy and how it's millimeter accuracy and so on. And when you're dealing with subsurface imaging, there's lots of different kinds of equipment, but you're not looking for millimeter accuracy. What you're doing is you're taking an as-built, which is pretty optimistic, drawn on a flat surface to begin with, and you're making a much better as-built. But in terms of accuracy, we're not trying to compete with an AutoCAD model. And that's kind of the next generation where things are going, and that's something that I know 4M is developing, wonderful 3D models for where utilities are and much better as-builts to begin with. And where things are going in the future is that we can go out to a place like that and verify and dial that in even a little bit tighter, and people can know about things in advance and save just piles of money. In terms of other contracts, aside from utilities and leaks and structural elements, steel reinforcements, the other stuff that GPR works really well for, we're starting to get more of is cemeteries. It's kind of a funny problem, but humans have been on planet Earth for a long time, and most of them are dead. It's a funny thing to really realize outside of archaeology is the vast majority of human beings are not currently alive. And so when you're dealing with most developed nations, hitting human burials can be a big problem. And GPR is, to my knowledge, I have a very strong opinion, the best tool I know of for finding burials, period. I used to do this the old-fashioned way, not that long ago at all. In fact, most CRM companies don't have any GPR at all. CRM being cultural resource management in America, that's what we call archaeology. They're going around and they're doing a grid of shovel tests and then saying whether or not they detected anything that looks like a grave, and that's great, except that it's nowhere near a 1% sample. And so statistically speaking, you could blast right through an entire cemetery and not hit a grave. I mean, it's crazy that people still, but it's considered, the way that until very recently that was the best that people could do. So legally it helps, that due diligence kind of an argument. But if you actually want to find the graves and not hit them with your bulldozers and stuff, you want GPR. And so we're starting to pick up a lot of cemetery work. And we just recently have one in Kentucky that's not published yet, but we found, I think, 5,246 burials in 5 acres.
Wow.
But we can do things like that. Right. And then that same cemetery can make decisions about where to stick because they need to run power lines for some of the monuments and stuff like that. And you can do it with a remarkable level of precision. So it can be done. And it's not, in the world of engineering, it's not even that expensive.
Wow. What are the, this is a bit of maybe a weird question, but what's the weirdest things that you picked up with GPRs? Like, what's your funniest story?
My first GPR survey ever. I was one of those. I read all the manuals. I knew exactly what I was doing when I went out there. And I was a PhD candidate archaeologist, so I'm pretty hot shot, or so I thought. And I'm working inside of a castle in Ireland. And this castle, it's huge and it's ruined and falling over. So I was personally the person to go around with a lawnmower and cut a path in the grass so that tourists could go and walk along the inside of this castle. And it's cool. A few weeks later, a guy brings out GPR. I'd never, I was, oh my God, we got to use this thing. But I collect the whole grid, and I see in my profiles, I can pick up this big red rectangle that's inside of our actual castle wall. And the historians had theorized there was an older Irish castle that had been resurfaced as a bigger Norman castle. And I said, we found it. Here it is. Here's a red map of exactly where it is. And it's right below this, but it's ruins. It's probably just the last little layer of stone that they didn't pick up. Yeah. There's champagne. The historians were thrilled. We got out there. We sampled it. And all I had found is where I had mowed the grass, the sun had dried the soil faster. And because of the water, it looked just like stone. It looked exactly like stone. And I was just totally convinced. So I found a whole phantom castle. It's my first GPR grid. I've never been that wrong again since, but I was totally wrong.
You learn the mistakes are what give us experience. So it happens to the best of us.
Oh yeah.
Yeah.
Oh, I was just gonna say it's one of those things where with GPR is people should be, in my opinion, when they get this thing, they're very nervous. I'm like, just go and be brave and just make sure that you state, like, we don't know anything. This is just what I can see and what it looks like. And you can say this looks like a stone object, and if you turn out to be wrong, well, that happens, especially when you're new. And a good client can look at your work history and they know what they're hiring. Are you somebody who's done this a long time for a big company, or are you a new guy? They understand. As long as you manage your client's expectations about how certain you are and how much you've done this, you shouldn't get in that much trouble. And what a lot of our clients do is when they go out there, they measure something and they get a really wild find like that. They'll say, "I want experienced eyes on this," and that's really what this project department is built around. They can just send us the data and go, "Guys, is there a sinkhole in the middle of this?" And we can look at it and go, "Oh no, dude, that's not a sinkhole." Like we find and can verify it. And so it's really nice because it's the same data set, and they can just there's that next level is available, and it's not even that expensive. Our rate for doing consultation is $225 an hour, which sounds like a lot, but most data sets 2-3 hours, a few $100, and you can know
Yeah.
if you're right or wrong. When we're talking about surveys with something that important, that's nothing. It's so cheap. And that's what I'm really proud of is for us, we get a really cool job because we get just survey reports from all across the world just rolling in and people finding weird stuff and going, is this really what I think it is? And it's an entertaining job, but you get really good really quick because I've seen just the wackiest stuff out there.
Yeah. Tell me a bit about the process itself. So how does it work? Like a company reaches out, they say, "Look, this is what we've done. This is a data set." What do you guys do? Like I know it's very might be a bit difficult to explain without images and without looking at screens, but maybe at kind of a high level. How does it work?
Yeah. So we do all the things when it comes to GPR. So people might have an idea for how something could work in theory. So they might be a drone company, and now you can buy drone GPRs. Actually, they're coming from places like Latvia, where all of a sudden you can pick up a fairly good GPR antenna for again like low thousands of dollars, maybe 10 grand or something, and mount this to a drone and survey. And they want to know like A, how well will this work with my current setup, and B, when they collect it, they might find that wow, this is way more complicated than I thought it would be. And we do this all the time, so I can answer their questions and I can help run through their data. And we just keep it as there's a same hourly rate for whatever they want us to do, and we're very mercenary. Like if you want me to go out to Bolivia and do this with you, or if you want to just send data to me and I just look through it for an hour, whatever you need, here's the rate,
Yeah.
and there they go. And so we get. It's hard to even say. Like most of our work is American, but we've got contracts with the United Nations just recently, working finding what they call clandestine burials. So unmarked graves relating to wars, particularly the Iran-Iraq War. Um,
Wow.
yeah, I just had a training session with the United Nations has a section that does this, and they're very good, experienced people. But the problem is that there's so much new software and equipment that comes out all the time that even if you have a team of PhDs, you constantly have to retrain. So people that are already experts will come to us for specific things that they don't know, and we will teach them. And likewise, I have other experts that I'll consult with when I get stumped, which is pretty regularly, about every 2 weeks or so. I have to reach out to maybe Dr. Dean Goodman is my favorite. He's the guy who wrote GPR Slice, and I go, Dean, what the hell am I doing? And he usually yells at me. But that's how it works when you're in the tech industry. It's just don't be afraid of getting into stuff you don't know, because when you do a GPR, there's so much to know about how GPSs work and how GPR works and how magnetic radiometry works and what kind of targets. You're never going to know all that crap. You're not.
Yeah.
Read the manuals well enough to do the data collection. We have online training courses that will really increase your odds of getting it right. And you can just rent equipment and try it. And odds are very high that we'll be able to get you through from A to B.
Are there any algorithms that you guys have I don't know developed, or is it like completely manual, or is there like some sort of combination to read the data sets?
That's a good question. So there are specialists who do exactly that, and they are software companies. And for a long time, the king of all of it for about 30 years has been Dr. Dean Goodman of GPR Slice. And in terms of software, I won't say he was unrivaled, but he was,
What was the name again? I didn't catch the name.
Dr. Dean Goodman.
Dean Goodman. Okay.
Yes, and he's fantastic. A bit grouchy now, but he's fantastic. He's a physicist who can also do coding, who also understands archaeology. One of those people that just has so much information in their head, it's unbelievable.
Yeah.
And so for a long time, he wrote the algorithms that you could pay not very much money in the world of software subscriptions, and you could have GPR Slice. And using Slice is a little rough. It's you have to know a lot of things to be able to use that software, and so we train people on Slice is one of our most common things. because there's so many things you can do with it that it's overwhelming. So usually when people say,
Slice is a software that you use to to analyze the GPR signals. Okay, got
mhm.
it.
And so when we like what we distribute, where people can buy Slice through us. So
Yeah,
they
yeah.
say, hey, I want to buy Slice, and we include like when you purchase it a 2 hour what we call an onboarding. And so I say, what exactly is your equipment, and where are you going, and what are you looking for? And so I can just dial in this huge capacity, this universe of crap you can do with GPR because it's just an amazing tool into what they actually need to know to do their job. And I record it on like a 2 hour session, and they can rewatch it and try it again and again, and it makes it really easy. And then we're there if it
Wow.
gets. Yeah, and so I try to just make it so you don't have to have three PhDs to do the job. You try to make things easy for people. In
Yeah.
terms of writing algorithms, a lot of this equipment nowadays comes with onboard software. So there'll be either a tablet that's attached to the machine or something that's built right directly on top of it. And those are getting better every day. I mean, when I started this in 2015, it was the Stone Age compared to what we have right now. And there's stuff that I can't even talk about because the developers on this go back and forth with us about what's needed and how blah blah blah. But we, the stuff that's coming out that I can't talk about is it's amazing. There's so many people working on algorithms for automatically detecting and drawing the things you see in GPR because the way it is currently done and will probably continue for a while yet is that you have to look at radar gram profiles which are measured in nanoseconds and understand what you're looking at. And training a human being to read a, a radiogram readout takes a lot of time. It just does. It takes a lot of
And
experience with it.
experience. And if someone
Yeah.
else is using it, so there's that human element that is unpredictable and that can mess up all your work. So
And
it's just
anytime you
how it
have to
is.
send out to experts who are qualified to read an unusual type of physics display, that adds a lot of time and a lot of cost. And we want GPR to be fun and easy. So the onboard software is designed to run automatic detection algorithms and draw utilities. Or I don't like to say that we see the utilities because unless you can follow it to a fire hydrant, you know damn well what it is. You know it's a linear object. And when you've done enough subsurface, you realize that there is just a mountain of crap that humans have put under the earth. And so even when you find a line, it may not actually be the one you were looking for, even though according to the as-built, this is exactly where it should be.
Yeah,
That might
exactly.
be an entirely different thing. Happens all the time. So
Happens all the time.
you find linear features, and if, especially metal objects in concrete or something, they just glow bright red in the new software. Like you can't miss them. And well, I shouldn't say that, but most of them are very easy to see. And there's exceptions to that because radar gets weaker and weaker signals that penetrates deeper into the earth. And quite often, when you get to the bottom, you can get phantom signals that look like something they're not, no matter how good you are.
Wow.
And quite often, the stuff you really, really need to see is at the bottom of what your antenna is going to reach, and you're in a spot where you can't just use a bigger antenna. And so they'll reach to us, and we'll do fancier algorithms and filtering and try to pull out that stuff. But uh, that's where like the software is going is more and more auto detection, more and more augmented reality. I love, people don't realize how great augmented reality is a tool. But when you have to explain to a client on site, no, I'm going to take this back and post process it. I'm going to send you some pictures of what's here. And then from that PDF, they're going to try and figure out what's in front of them. Nobody on an
Yeah.
excavator wants to be handed that PDF. They hate
Yeah.
that. My
Yeah.
new thing is I love KMZ files, which is Google Earth. I can send that in a text message, and their accuracy isn't going to be amazing. But the guy in the excavator can see it on his phone and go, "Oh shit!"
Okay. Yeah,
I
I
see
get
where
it.
I'm just flagging my little annotations usually. Although I can even export a time slice, so I can show you this is what's below you, 1 meter below the ground, and they can see a big ass sewer line or something. And go, ooh, don't put the there.
I'll get off the shovel for a second.
Right, right. Um, and so we're getting to where the stuff is eminently more shareable. It's much faster to process. So our processing time. I have a company in Chicago we work with a lot that does great big cranes, and they can be up to 500,000 tons. And when something is that heavy, they ran into trouble once where they put it over. I don't know what utility it was. I imagine a sewer line, but something hollow, and the crane went like this. And when you have something many stories tall weighing that amount and it moves suddenly, the liability is just unimaginable. That could go down and hundreds of people get killed. I mean, just
Yeah.
crazy.
Yeah.
And so finding these things and being very sure that you're right, not just that you did your due diligence, is very important. And relative to that level of liability, the cost of GPR scan is just negligible. I mean, and most of these companies, they'll have someone like us come out and we'll do scans, or they might start with something cheaper, and that's a bad idea. With something like that, you should go for some. We're not expensive. And there's local people who go around doing utility locating with just a handheld, and they're pretty good, and they'll mark it with flags or spray paint, and that's okay. But if they're not doing post processing with computers, they're not pushing the limits of what this stuff can find. So when you need to be right, you send the data somewhere to get post processed as an extra step or a line item in the quote. It's not much money, and you get experts to look at it and say, okay, here's what's really here when we draw this out in 3D models and really look at it.
What do you think that is? That um, I don't know that the quality of this data, excuse me, that the data of this quality is just sometimes overlooked. Like it's sometimes, we hear, and this is not to knock off the locators and the 811 guys, but sometimes they get called in 3 days before construction starts and like, okay, like we've done the markings, we're not liable anymore, but that's like they're working with their data, or and they're taking on 20, 30, 40 projects a day depending on where they are in the state, and like there's a limit to the quality that they can give for such a delicate situation. You know what I mean?
Yep, and there's two big problems with that. And the first problem is the old expression: it's not the arrow, it's the Indian. Not everyone holding on to utility locators equally likely to map your utilities well. A lot of people, you can buy this equipment. It's not that expensive as far as business expense. If you can afford a car, you can certainly afford a utility locator. And you can go out there and say, I'm a utility locator, and there is no one who will arrest you for saying that. You can't be wrong. You have the device in your hand. You are technically a utility locator. Whether you're any good is completely separate. And the industry is so young that it's full of what I call cowboys. And I don't dislike them, but they're usually young men fresh out of school who will buy the equipment, read the manual, and go out exactly what I did at my castle.
They're businessmen. They're entrepreneurs. They want to make a living.
Right.
I
I think they're great. And it's our job to reach out to them and shake them and go, guys, don't do that without someone double checking your work. You really need that because you're going to get sued and it's going to cost you a lot more than being right. So we have a utility locator, usually sits in that chair right behind me, but he's in the back training some people. And he's very, very good. But utility locating is not simple. There's actually a lot of context into figuring out where things are, even with the wands. And the GPRs levels beyond that, where we're actually doing something closer to AutoCAD, where we're building a nice 3D model with much more accurate understandings of things. And that's the first problem, is just making sure you have a good utility locator. And if that's not finding everything in your as-built and you think there's extra stuff there, a GPR survey is the next level, which for an expensive project, I would just assume do. Like if you're buying land, before you even send it to an architect, have someone find out where all the utilities are, then design. And that's the order it should go in. But the next problem is what's called BIM, or Building Information Management Software, BIM.
Sure.
And what people don't realize is that we kind of take for granted what software can do really quickly, and we trust it. And when you convert projection systems, and this is the big problem in America, and I imagine it's a problem elsewhere, everybody has different kinds of projection systems. Our surveyors are absolutely not using a global projection system like WGS or UTM. They're not doing it. They're doing a local system like state plane, and they have to because all of the legislation and regulations are written in coordinates using those planes. And they can be very old. They are quite often projections from the 1920s and 1930s. And when you convert what I'm doing in UTM into what they're doing in state plane, they might be two sets of completely accurate measurements, but you're stretching them over a shape of the Earth that's not projected the same way. So both very accurate measurements can be a foot apart. And that's very hard to explain to people, is the projection system, tying those together requires an expert. So it's not that it can't be done, it's that BIM is kind of a new concept. And unless you have really good AutoCAD and really good surveyors who actually know how to convert coordinate planes, people just think they can drag my locations and their surveyor's locations and the plumber's locations into the same file and everything will be in the same place. It's not. It just is. It's not plug and play yet. And I probably 10 years from now, that'll be completely outdated. And, people just drag it and it'll show up in the right place. But it's not there in 2022. So if you want to take your GPR data and put it on an AutoCAD model, you can, but you need somebody who can convert coordinate planes very well, and you need somebody who understands tolerances. And the only industry that really can do that well is surveyors. And so you need somebody that can say, I can have an architectural diagram of where these metal beams are that's accurate to 2 millimeters. But I can then add GPR data that when we're penetrating 4 feet of concrete, I'm really happy if I'm within 5 centimeters. It's a different level of accuracy. And dealing with those data sets when you're drawing a 3D model and you have different types of accuracy is actually really heady stuff. It's not simple. And that's where I find a lot of our clients turn out okay because we know to warn them in advance. But that's where a lot of people fall into pitfalls before they call us, is they say, hey, I did this with an RTK enabled GPS and I've got 0.7 centimeter accuracy. Why am I 18 inches from my target? It's like, well, they're in a state plane and you're not, and their world is flat and your world is curved, and I'm sorry. Like,
Yeah, science,
yeah, and it's a real pain in the ass. And it's one of those things where once you understand what's going on there, it's like, oh, it's not that hard. And yeah, you have to hire a specialist to fix it, but the way things are going nowadays is so much of this is remote, and exporting parts of a job to a bajillion different subcontractors isn't that hard like it used to be. And so you can send this crap to a surveyor and go, hey, dude, can you convert this projection system for me? And they're like, yeah, like a few $100. It's not a big deal. It's just a matter that the person who's actually running these projects needs to understand it is varying levels of accuracy, different projection systems. That's about it.
I think that our industry at the moment, construction, infrastructure, utilities, is prime for these new techniques, these new technologies. In so many cases, they're just not new, but they're just so trivial in so many other industries. Like you mentioned medical before, and like we can, we were talking about algorithms. Like there's all these stuff that are happening everywhere else except for construction and except for infrastructure. And it's, I think it's like the professionals these days are getting impatient. It's like, okay, where's the innovation? Where's the new stuff that we can start working with? And I think there's a lot of internal education happening inside organizations at the moment, whether it's with project owners like TechStad, or whether it's the big GCs, or the like tiny civil engineering firms of 5 people. Like people are ready for this type of stuff.
Absolutely. And I think what's frustrating is we all see manufacturers showing us what this equipment is capable of, what this data can look like.
Yeah.
And we're all going, why isn't this being used? And what people don't understand is when you have different crews running different equipment, there's a million ways to set up your GPS. It's infuriating how many options there are on these things, because once you have them all set, it's like, dude, I just turn it on and I run it. Like, it's really easy. Different settings, and they have to be that way because of the different backgrounds and legal requirements and regulations. And so getting all these data sets to play together is where the magic is happening right now. And that's where companies like 4M are coming in and being able to tie all this together into just one big stupid map. Here's where the stuff is, guys. And that people don't respect how much calculation that requires and how clever you have to be. I know you guys have things going on with satellites looking at auto detection algorithms, what do you call it, AI, looking at where people have excavated trenches to help figure out where some of these utilities have been dropped. And stuff like that is required to produce what is ultimately a very easy to use deliverable, where once you're done, any idiot will be able to click on it and go, oh, look, a water line. It's great. But people don't understand that transition is taking place slowly because there are so many different crews and so many ways of doing this, that getting all that into one universal package is just a lot more math than people respect. And that's where my advice to people getting into subsurface and GPR is, don't do that. That's not your job. You're there to collect data that is very accurate and send it to them with that accuracy presented. Here's how accurate my GPS was. Here's how accurate depth estimates are with GPR, because it's measuring in nanoseconds, and no AutoCAD out there is going to be in nanoseconds of depth. They're going to do it in some sort of actual inches or centimeters. And so you have all these tolerances going on. You state them, you collect your data, you present the data in whatever file types they want, and then you say, there you go. And if they are trying to do something and it's not compatible with their system, they need to hire a professional that can take different data streams and combine them together. And then that's usually like a surveyor, basically. And it's just that knowledge that you have to get the right person. Because right now, when I'm a guy with a GPR, people are going to say, great, can you stick that in my AutoCAD model? No, that's not me. I find the pipes, I record them on my thing, and I send that to you. And it's just that matter of GPR as it stands right now is so great at producing these very, very useful PDFs of where we detect things. And then the next step is just getting that into an automated system that models it. And that 5 years from now, probably that'll be so much easier. But right now, that's where the headache is.
What do you guys do? You mentioned conflation before. Do you guys have any challenges with conflation and putting all the data together? Like, have you had any complex data sets that you said, okay, like this is something that we need to give some thought?
Yeah. So my statistics professor taught me the first rule of statistics is GIGO, garbage in, garbage out. If I get a data set, and I have learned this the hard way because there's so many things you can do to try and clean up GPS points. But if you get a data set and you open it up and the GPR data is way too noisy, way too shallow, or the GPS points aren't good enough, say, I'm sorry, you're going to have to recollect this. I can't take it. And that's really hard. And everyone who does GPR has that day sooner or later. And it doesn't matter how good you are. Once in a while, you're on some volcanic sand in Peru and you find out your penetration is that deep. Like it's rare. It's I think probably the highest success rate non-destructive testing there is. But if you do this long enough, you will get burned once in a while where you collect the data set and say it's not going to work, guys. I'm sorry. And that's a hard lesson because I've had especially like PhD candidates where you get a big grant and you go out there and you do the thing and you say, I have spent the grant money. Here's my data, and you go, ooh.
That hurt. I felt it.
I need you to fly back out there. It's not good. But that's the problem is your first time doing something. If you're doing something completely new, it's fairly high risk. And so that's why I'm so happy we now offer just like completely online training. And it's like a 2-week program, but at least you will be able to know if your data is good and you can mail it back to wherever you rented it, or if you need to change a setting and do it again. Because I personally collected, I don't know how many grids where I'd find out, stacking was on. What happens with stacking? Well, I go here and I delete it all, and I go back out there and do it with that not on. That could be a very expensive thing to find out. You take a 2-week course, not that bad, and you can look at the screen and kind of review your data and go, okay, I have good GPR data, and then GPS points are pretty easy because it'll show you a track, and you can say, are these GPS points where they belong? Yes, great. So the first rule, if you have good data, from there you can take a deep breath and things will be okay.
Yeah.
And that's the biggest filter I find with new people and people who just buy this stuff. It's not that bad. You just need to make sure you get to the step where you have good output. And from there, it's just a matter of what can be done with it. And, GPR, like everything else, it's limited. Obviously, depth is a limitation. You can't take a concrete scanner and look at something 2 miles under the Earth's crust. It's just not in the books. And the frustrating thing for me forever is people ask me, how deep is it going to penetrate? What's the RDP of your soil? I don't know. There's no map of soil RDPs for planet Earth. It doesn't exist yet. So I can estimate, I can tell you kind of a bell curve, like 95% confidence you're going to get down 2 meters kind of a thing. But 5% is not that rare. It's like that 5% chance of rain on the weather forecast. About 1 in 20 times you get rained on. It's the same kind of a thing. So occasionally people will take a grid and they'll pay a lot to rent a machine and they'll find out, well, I needed things that were 3 meters, but I only see 2 meters.
Yeah. Are you putting together benchmarks internally, like to kind of log the data and say, okay, this is what we've learned here, and this can help us make sense of these other projects? Like, is that something that you guys are doing, like to give to your to the customers and the agencies that you're working with, kind of feedback? Look, like this is typical for your type of project that you've dealt with, or this is abnormal?
Yes, and in fact, my favorite benchmark is we have on our contract, and people can change this if it needs to be the higher security and they need information security.
Of course.
Usually, most of our projects are totally fine with our indemnification clause, where we say we can take this report and show it to future clients so they know what their stuff could look like. And so I have a huge catalog of these, but I can try to match exactly that antenna or one very, very similar to their kind of an area and their kind of a target. And I can grab that PDF and say, this is what we're going to try and do. I can't guarantee it'll work, but this is usually very, very good. And I can calculate. I've gotten awfully good at quoting how long it's going to take and how long it's going to cost, how much it's going to cost. And we go out there and we do the thing. But my favorite way to approach this, because people just don't know what the deliverable is going to look like, is to just send them, here's a Google Earth file of what we found at a site in, let's say, Hawaii. Here's a PDF. And so we can do that same thing for you. Here's the quote. And they can just look at bop, bop, bop and know what they're buying. And that's really the biggest thing I found, is at the end of the deal, whether or not that client is happy is mostly established at the beginning when you told them what to expect.
Yeah, of course.
And I can't tell you how often people think that because we're making a 3D model, that we're giving them some sort of 3D model. Like, no, I'm processing that, but unless you own my same software subscriptions, I'll share you the file. But unless you have GPR slice, you can't even open it. And even if you do, you need to know radio physics to do much with it. If we're not there yet where we have easily shareable 3D files. It's getting there. Things like Google SketchUp and all those, where we're starting to get cheaper and cheaper 3D models that people can actually share to each other. But it's just not quite there. And so for the time being, when we export what's called tomography, which I know you know, but it's slices of flat information. And if you look at medical imaging, that's how it's generated. So there's just a whole bunch of these little flat slices close together. It's like a book with pages. And we can export those as file types that are nowadays pretty common. It's pretty easy to share a flat thing, even if it's georeferenced with points for, like, Google Earth, for example, is my favorite one. You can just send them all those flat things and they can look at it. And if the target is something like a metal object, you can just see the red line and know where it is. And so anybody who's got AutoCAD, I can send them that tomography, and if they're not an idiot, they can draw the pipes in it. But it's on them, because they're trained to know how to draw pipes and deal with the appropriate level of accuracy, and not say this is 1 centimeter accurate when it's 5 centimeter accurate and get somebody electrocuted. I'm not going to draw that model for somebody and hand it off and have them completely misunderstand it. They have to draw that model right now. And maybe in the future that'll change. But for the time being, the biggest thing about geophysics is to keep it geophysics. It's complicated enough. Run the data, produce the very common, everybody can take .kmz files anymore, but whatever they want, you can export as, send them whatever type they want, and say, my interpretation is a PDF file. There you go. Here's the object. Here's what I think about it. And then anything they want to do from there, as long as you don't jump into the middle of it, you're fine. Just don't pretend to be an AutoCAD engineer or a surveyor. That's not us.
Yeah, not can't be liable for everything.
No, and I like it. I really like it because people, they get so snooty when they compare us to stuff that's surface and very high accuracy. And I go, you're comparing us to the wrong thing. Compare me to your as-bills. That has a surveyor's stamp. All right, that's a huge legal meaning when a surveyor stamps something. And if you buy a house, that surveyor's stamp, they may not have gotten out of their car before they stamped it. They drove by and went, that's the house, boom. Because the level of accuracy required in that situation to be a surveyor-grade accuracy, it's, what can you do standing on the surface being a surveyor? We're able to do something much, much more accurate than that. So in that context, we're just smearing what the surveyor has stamped, because we can actually have some sort of clue what's going on under the ground. You can get better than what's being done subsurface very easily. Like, compared to what's been done 10 years ago, it's not hard to get a much, much, much better idea of the utilities and the other stuff going on inside the geology and depth of concrete pads, which all the time people lie about. And they say, oh yeah, it's a 5-inch pad. You find there are sections where it's 3.5 inch. You get to something, you go, did they run out of rebar over there? What happened on this spot? And we find a lot of times people are calling us because there's a building that's not that recent, but something's going wrong with it, and they want to know how much worse is this going to get. Tensioning cables that are very, very large, post-tensioning cables holding together the apartment complex. We had an example where those were popping out of the floor, which is a bad sign. And they want to know, is this sign. Can we just fix these floors and we're good, or is this building going to, and I'm not an engineer. I'm not going to tell you that. But I can scan this and tell you where the metal objects are. And that's, you hand that to an engineer and they can tell you a much more educated understanding of what's happening.
Yeah.
Just don't be the engineer, be the guy who finds the linear objects. And there.
Yeah. Uh, Sean, we have normally we end episodes with two questions. So my first question is, what do you think that industry experts, industry professionals need to emphasize most in their projects when they're dealing with GPRs?
Uh, the most important thing is not expressing a level of certainty or detail that isn't appropriate. It's not hard because it's always the same. We're never 100% certain, but here's how accurate my GPS was, and here's what the GPR recorded. And in terms of depth, there's some articles we can cite, but if you've done hyperbola fitting, which is what most people do nowadays, you've got about 10% accuracy on your depths. So however deep it down it is, the tolerances change with depth. But that's usually when people are looking for a pipe, 10% accuracy, they can work with that, on the depth. And the XY is very accurate because it's on the surface. And so, just knowing there's really fundamental basics that almost every survey follows the same rules. And so if you have gotten any kind of training on GPR, don't just read a manual, a class. I think ours is probably the cheapest and fastest out there, but there's college courses on it. I know Colorado School of Mining with Lawrence Conyers has you can get a degree in this stuff and be an expert. But whatever it is, just make sure that you had at least the fundamental basic training so you don't say something you can't do. Don't make a promise you can't keep. As long as you're doing that, you're really going to be just fine because this stuff produces such an unbelievable product at such a cheap price. It's pretty easy to keep your clients happy. It's just a great map. And then they look at the price and they look at how much it saved. This is great. You have saved hundreds of thousands of dollars because I've had cases where they were just going to put a highway right through a whole row of what worked out to be African-American burials. It's like, oh God, no, scoot it, just a short distance, cost them probably almost nothing, and you're fine.
No more ROI questions. Just kind of drop the mic. This is what we saved you guys.
When you do geophysics correctly, you will have, like anything else, you'll have some good contracts and bad contracts. But most of the time, they should look at the product and they should look at the bill and almost just laugh and sign your check. Like this is a great product for the money. And the biggest problem right now is there's not enough people that can even give them that product. There's so few people doing this. And so it's just this vacuum market that's going to explode. There's going to be a lot more GPR techs in 2025 than there are right now. So if you're getting in, people getting into this now, it's easy. It's really easy to really impress some very high dollar, great engineering firms because they haven't had anybody do this that wasn't just some wild asshole who didn't know what he was doing. When you're the first person to walk in and give them the correct deliverable that wasn't that hard to produce and it just blows their socks off, that's a great feeling. I like when there's really high dollar, expensive people. You're in a room, there's a big table, and they've all got the hard hats with all the crap attached to them. You go, here you go, guys.
All important. All have an opinion.
The cheapest antennas you can get right now I shouldn't say that, but that I know of off the top of my head for concrete scanning is like the ProSec. They have augmented reality. And so I run a scan and then I take a picture of a little barcode and I just hand the client my tablet. And I go, look, those are linear objects, blah, 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 blah. But they see the freaking rebar and they know what they're looking at. And they're just looking, you can stand next to it and point at it and go, what the hell is this thing? And they go, oh my God, that's not supposed to be there. They know what they're looking at. They're thrilled. And I love that feeling when you leave a room and your clients are just absolutely giddy. That's
nice.
The potential GPR experience when you just solve their problem for so little money so quickly. I love that feeling. And it's just full of that. It's a really good job right now. So I love my job.
Yeah. So last question. Who do you think is the next person that we should have on our show?
Oh boy. Well,
I put you on point there.
Yeah, I'm biased because I just had a very long series of meetings with Bill Stetner of Emlet. And Emlet is this corporation. They're a manufacturer that makes GPS. And we are a distributor. We sell them. And when I first encountered an Emlet, I was so skeptical that I didn't even give it really time because I had come from Ireland. I'd used terrible GPSs, and we didn't basically thrown them out and gone back to using like total stations. It was really slow, but at least you have something. And so I showed up for this job, and my boss handed me a $3,000 GPS. And I said, "Oh, good, great, thanks, Dan. I'm just going to take my quarters with total station anyway." Because this is going to be crap. And I've used them again and again and again. And I've used them in shockingly thick forests. and I have yet to stump my emlets. They have worked in unbelievable situations. Their RTK accuracy, you can't really get a much more accurate GPS. And they're $3,000 a head, $4,500 if you want a pair. They're stupidly cheap. The whole how they got them that cheap, the whole story, and Bill Stetner of Emlid would happily sit here and tell you all about it. But the fact of the matter is that pretty much everybody can afford to have really good GPSs now. It's a total game changer in the world of locating anything. They're easy to use. They're cheap. I have dropped them off of all kinds of things. If you manage to break it, their warranty is very, very good. And they're not going to say, well, mail it to Sweden and we'll fix it and send it back to you 6 months from now. They don't fix them. If you manage to break it, they're just going to send you another one, unless it has like a bullet hole in it or tire tracks through it. It takes a lot to break those things. I should know.
So a must have for the guys in the field.
Absolutely. I mean, they're durable and they work really well and they're simple to use. And I can't believe I'm saying that about an RTK corrected GPS, because I've used a lot of other systems out there and they're very good, but man, you got to have a college degree to wield some of that stuff.
So you owe me an intro, Sean. And we'll make it happen.
All right.
Okay.
Well, very much.
Sean, thank you so much. Very much appreciate your time, and it was a pleasure. Learned a lot of new stuff, and hopefully we'll have you again another time. So thanks.
Anytime.